welcome to the deep dive. Thinking about the material you shared with us, especially that piece on the evolution of human-computer interaction, it it really struck me how much prompt engineering is becoming this critical skill.
Hmm.
It's not just typing a few words into a chat window anymore.
Not at all.
We're really looking at the art and science of crafting inputs that truly unlock what these large language models can do.
Absolutely. And, when you think about your notes on how AI is getting more sophisticated, especially in creative fields, well, figuring out how to guide these prediction engines effectively, it's becoming essential.
Right.
It's about getting past just basic interactions to outputs that are, accurate, nuanced, and actually meaningful. That's really the core of what we'll unpack today.
Exactly. So we've dug into this really comprehensive white paper on prompt engineering. It's got your shortcut, to understanding how to get the absolute most out of these LLMs.
Yeah. A shortcut's a good way to put it.
Whether you're trying to summarize, complex documents or generate pretty sophisticated code or even push the boundaries with creative writing, which, thinking about your background, those are all areas you're interested in.
They are, yeah.
So effective prompting is really the key.
And the white paper really hammers this home. It's so important to remember that fundamentally LLMs are prediction engines.
Prediction engines, right.
They take your input, look at their massive training data, and predict the most likely next bit of text. The skill in prompt engineering, then, is guiding those predictions precisely where you want them to go.
Okay, so with that foundation, let's dive in. One area that maybe you don't think about it immediately, but the white paper highlights it as, surprisingly important, is configuring the LLM's output.
That's right. It's not just about the quality of your prompt, your input. How you shape the output can make a huge difference. And a really basic part of that is output length.
Output length, okay.
This setting, it just dictates the maximum number of tokens the LLM is allowed to generate.
Right, so more tokens usually means a longer response. Pretty straightforward. But the white paper points out a really critical detail here, doesn't it?
Right.
Especially thinking about some of the document analysis work you do.
It does, yeah. So while a longer output definitely uses more compute resources, which can mean more costs, slower response times, all that.
Right.
Simply cutting the token limit doesn't automatically make the output more concise or focused. It just chops it off.
Oh, okay. A hard stop.
Exactly. A hard stop. It just hits the ceiling and stops. And this is super relevant in techniques like React, where you need to manage that length really carefully so the model's thought process isn't cut off too early, before it gets to a useful point.
That makes total sense. Yeah, it's not summarizing, it's just stopping.
Right.
Okay. Now, the white paper then gets into the pretty fascinating world of sampling controls. This sounds like where we can really tweak the personality or the style of the output.
Precisely. LLMs don't just pick the single most probable next word, right? They generate probabilities for a whole bunch of potential next words. Sampling is, it's the mechanism the model uses to pick which of those possibilities actually becomes the next part of the output, and there are a few key controls for that.
Okay, let's get into those. First one is temperature. We hear this term thrown around a lot, especially when people talk about AI creativity. What does adjusting the temperature actually do?
Okay, think of temperature like a dial for randomness.
Okay.
A low temperature, say, around 0.2, makes the model more deterministic. It'll lean heavily towards the most probable next token, time after time. That's great for tasks where you need factual accuracy, consistent answers, maybe that data validation work you mentioned.
We'll keep it predictable.
Exactly. But a higher temperature, maybe 0.9, injects more randomness. So you get more diverse, sometimes unexpected, maybe even creative results. The white paper uses this analogy to the softmax function, basically saying temperature scales the probabilities, making less likely words more or less probable depending on how you set it.
So for generating structured reports from data sets, you'd want a lower temperature. But maybe for brainstorming, wild marketing ideas, cranking it up might spark something interesting.
That's the idea, yeah.
Now, what about top K and top P? They sound like they're also about sort of narrowing down the options.
They are, yeah. They both focus the model's attention on the most likely next tokens, just in slightly different ways. Top K sampling is pretty simple. It just tells the model to pick from the top K most probable tokens.
So if K is 10, it only looks at the 10 most likely words.
Exactly. A higher K lets it explore a bit more. A lower K makes it more focused. And a K of 1 basically forces it to always pick the single most likely word. That's the most deterministic you can get, essentially.
Okay. And top P, how's that different?
So top P, or nucleus sampling, it works a bit differently. It looks at the whole probability distribution for the next token,
Hmm.
and it picks the smallest group of top tokens whose probabilities add up to a certain threshold, P.
Okay, so cumulative probability.
Right. For instance, if P is 0.9, the model adds up the probabilities of the most likely tokens until it hits 90%. Any token outside that set just gets ignored.
Ah, I see.
So, similar to top K, a lower P makes the output more focused, predictable. A higher P allows for more variety. The white paper, quite wisely, I think, suggests you should really experiment with both and even using them together to find what works best for your specific task.
So you can layer these filters, like use temperature and top K and top P.
Exactly. When all three are active, the model first figures out the set of tokens that satisfy both the top K and top P rules.
Okay.
Then the temperature setting gets applied to adjust the probabilities within that filtered group before it finally picks the token. If you only specify, say, top K, it just uses that. And if you don't set a temperature, it just randomly picks from the tokens that made it through the top K or top P filter.
That's really helpful, actually, understanding how they interact. The white paper also gives some, like, general starting points, right? Based on how creative you want the output to be.
Yeah.
Could you recap those?
Sure. So for outputs that are, generally coherent but maybe have a little creative flair, they suggest starting around temperature 0.2, top P 0.95, and maybe top K 30.
Okay.
For really creative stuff like those marketing angles, you could try pushing temperature to 0.9, top P to maybe 0.99, and top K to 40.
Higher numbers, more creative.
Generally, yeah. If you need things more focused, less creative, maybe try temperature 0.1, top P 0.9, top K 20. And for tasks where there's really just one right answer, like maybe solving a specific math problem or a coding thing, a temperature of 0 is often the way to go.
Those are great starting points for playing around. Now, the white paper also warns about something called the repetition loop bug. Given your experience debugging code, that sounds familiar, maybe in a different context.
Oh, yeah. It's a familiar kind of frustration. It's basically where the LLM just gets stuck. It repeats the same word or phrase or even a whole sentence over and over. And the white paper explains this can happen with sort of badly chosen temperature and top KP settings. And surprisingly, it can happen at both low and high temperatures.
Really? Both ends?
Yeah. At very low temperatures, the model can get too fixated on the single highest probability path and just keeps predicting it. But at very high temperatures, all that extra randomness can sometimes, just by chance, lead it back to a state it was already in, and then boom, you're in a loop. So fine-tuning those sampling parameters is often how you break out of it. Sometimes just nudging the temperature up slightly from 0 or tweaking the top K or top P to allow a bit more variation can fix it.
Okay, so it's a delicate balance then.
Yeah.
Predictability versus novelty.
Right.
Now that we have a better handle on configuring the output, let's dig into the real core here. Prompting techniques. The white paper outlines quite a few, starting with the most basic one.
Exactly. The simplest approach is what they call general prompting, or sometimes zero-shot prompting.
Zero-shot, right.
This is where you just give the LLM a description of the task, but you don't give it any examples of what the output should look like. Kind of like saying, hey, summarize this paper, without showing it what a good summary looks like first.
And the example they used was classifying a movie review.
Yeah.
Right? Something you might do when looking at customer feedback.
Precisely. The goal was sentiment. Positive, neutral, or negative. They used, I think it was the Gemini Pro model, set a low temperature because they didn't want creativity, just classification.
Made sense.
And the prompt was super direct. Classify movie reviews as positive, neutral, or negative. Review. Her is a disturbing study. I wish there were more movies like this masterpiece. Sentiment. And well, the model correctly spat out positive.
Simple enough.
Yeah, but the white paper makes another really good point here, something I know you appreciate from managing complex projects. The value of documenting everything.
Okay.
Like using that table format they showed, tracking the prompt, the model, the settings, the output. It's crucial for systematic work.
Absolutely critical if you actually want to improve things over time.
Yeah.
Okay, so what happens when that simple zero-shot prompt just isn't enough?
That's when you start giving examples. We move into one-shot and few-shot prompting. A one-shot prompt includes just a single example. Here's an input. Here's the kind of output I want. A few-shot prompt gives multiple examples, showing the model the pattern or the structure you're aiming for.
So the idea is basically teaching the model by showing, not just telling, especially if you want a specific output format or maybe a certain kind of reasoning.
Exactly that. The white paper mentions a general guideline for a few shot is maybe 3 to 5 examples,
Okay.
but, that can really vary. More complex task might need more examples. Also depends on the model's input length limit. You can't just stuff infinite examples in there, especially with long documents.
Right. Practical limits.
They had a really clear example for few shot parsing pizza orders into JSON.
Oh, yeah, I remember that one. They gave it a couple of examples, like pepperoni pizza, large maps to this JSON, veggie small maps to that JSON,
Right.
and then asked it to parse a trickier one, like a half-and-half pizza order.
Exactly. And by seeing those first couple of examples, the model learned the structure, the fields it needed, and it managed to correctly parse the more complex input into the right JSON format.
Nice.
And they also stress how important it is to pick good examples. Relevant, diverse, high quality. And if you know you're going to run into weird edge cases like unusual product names or maybe ambiguous requests, try to include examples that cover those. It makes the model much more robust.
Makes perfect sense. You're basically prepping the model for the kind of stuff it's actually going to see.
Ah.
Okay, next up, the white paper talks about system, contextual, and role prompting. These sound like different ways to give the model a broader sense of direction.
They are, yeah. And honestly, there can be a fair bit of overlap between them in practice.
Okay.
System prompting is about setting the big picture, the overall context, the main purpose for the LLM. It defines the fundamental job you want it to do, maybe translation or classification or summarization. Think of it like the stage directions you give before you give it the specific line or input.
The white paper showed using a system prompt to say the movie review classification should only output the label in all caps, right? Which could be useful for standardizing output if you're feeding it into another system.
Exactly. And another example showed using a system prompt to force the output into JSON format, which again is super useful for structured data processing. System prompts are really versatile. You can use them for structure, for tone, even for safety, like instructing the model to be respectful and avoid harmful stuff.
Okay, so system prompts set the overall rules of the game. What about role prompting? That sounds like giving the AI a personality almost.
Yeah, pretty much. Role prompting is where you assign a specific character or a profession or some identity to the LLM. This helps it generate responses that fit the knowledge, the tone, the behavior you'd expect from that role.
So you could ask it to act like a, I don't know, a seasoned history professor when explaining something.
Exactly. Or a really friendly, patient customer service agent. Or a pirate. Whatever fits.
The travel guide example in the paper really showed this well. The suggestions, the whole vibe really shifted when it was asked to be a humorous travel guide versus just a generic one. That kind of control over style could be really powerful for creating engaging content.
Totally. Giving it a role gives the AI a kind of mental model to work from. The white paper even lists some styles that work well, like prompting for a confrontational style, or descriptive, formal, inspirational. Depends what you need.
Interesting. And then the third one was contextual prompting. This seems more about the immediate information, the background for this specific task.
That's exactly it. Contextual prompting means feeding the LLM specific background details that are relevant just for the query or task you're giving it right now. It helps the model grasp the nuances and tailor its response better.
Right.
The example they used about generating blog ideas for retro 80s arcade games was perfect. By giving that context retro 80s arcade games, the model came up with much more focused and relevant topic ideas instead of just general video game stuff.
Okay, so system prompt sets the big goal, role prompt gives it a persona, and context prompt provides the immediate need-to-know info. And you said these could work together.
Absolutely. Often, a really effective prompt will blend elements of all three to give the LLM really clear guidance. The trick is just understanding what each technique is best for and how to combine them effectively.
Got it. Now, the white paper moves into some more advanced techniques, starting with step-back prompting. Sounds intriguing, like making it think more deeply.
It is. Step-back prompting is a neat trick to boost performance on tasks that need complex reasoning. The idea is, before you give the main specific prompt, you first ask the LLM a more general but related question
Okay.
to kind of activate its relevant background knowledge on the topic. Then you take the answer it gave to that general question and feed that back into the prompt for the specific task as extra context.
So it's like getting the LLM to zoom out and look at the bigger picture before focusing in on the details. The video game storyline example really showed that, didn't it?
It did, yeah. First, they just asked for a challenging first-person shooter storyline, and the result was kind of, generic.
Hey.
But then they first asked a step-back question, something like, what are common engaging themes in FPS games? They took the answer to that and put it into the next prompt with the original storyline request. And the result was way more interesting and specific.
That's really clever, tapping into its broader knowledge base like that. Okay, next up, chain of thought, or COT. This one's been getting a lot of buzz lately.
And for good reason, chain of thought, COT prompting is super powerful. It basically encourages the LLM to spell out its intermediate reasoning steps on the way to an answer. Instead of just asking for the final result, you nudge it to, like, show its work or think step by step.
And that helps with complex problems.
Massively, especially problems that require multiple logical steps to solve.
And the white paper listed several advantages, right? Like, it's pretty easy to implement.
Yeah, low effort.
It can significantly boost accuracy for existing LLMs. It makes the reasoning clearer so it's more interpretable.
Right, you can see how it got there.
And it seems to make the results more stable even when the underlying model gets updated.
All true. The main trade-off, of course, is that the output gets longer, which means potentially higher cost and more processing time.
Right. The math problem example in the paper was a great illustration. Asking for the partner's age straight up gave the wrong answer.
Completely wrong, yeah.
But just adding that little phrase, let's think step by step, suddenly made it generate the correct reasoning and the correct final answer.
It's kind of amazing how effective that simple instruction can be. They even showed how you can guide it further using few-shot SUT, giving it examples of step-by-step solutions.
It really highlights how guiding the process can improve the outcome. The paper also mentioned 2T is good for things like code generation and creating synthetic data.
Yeah, basically any task where a human would naturally break the problem down into smaller logical steps is probably a good candidate for chain of thought.
Okay, building on COT, the white paper then introduces self-consistency. This sounds like a way to make the answers even more reliable, maybe.
That's the idea. Self-consistency starts by acknowledging that even with chain of thought, an LLM might come up with slightly different reasoning paths if you ask the same question multiple times.
Right, because of the randomness from temperature, even if it's low.
Exactly. So this technique involves prompting the LLM several times, usually with a relatively high temperature, to encourage different lines of reasoning.
Okay, get diverse paths.
Right. Then you look at all the final answers it produced across those different runs, and you basically take a vote. The answer that appears most frequently is considered the most likely correct one.
Ah, like crowdsourcing the answer from the AI itself. The email classification example they used, where it gave different classifications and reasons on different tries, really showed why you might need this.
Exactly. It gives you a higher degree of confidence in the final answer. The big downside, as the paper notes, is the cost you're running the same prompt multiple times.
Makes sense. Trade-off between cost and confidence. Okay, next. Tree of thoughts, or TOTI. This sounds like COTI on steroids, maybe.
You could say that. Tree of thought, TOT, is basically a more generalized version of chain of thought. Instead of just one linear sequence of steps, 2T lets the LLM explore multiple different reasoning paths at the same time, kind of like branches on a tree.
Wow.
This makes it really good for super complex problems where you might need to explore various possibilities, maybe backtrack if one path isn't working out and try another.
That sounds incredibly powerful for really thorny problems where the solution path isn't clear up front. Okay, shifting gears a bit. Let's talk about REACT. That stands for reason and act, right? This seems to connect the LLM to the real world, or at least external tools.
It does. REACT is designed to combine that natural language reasoning we've been talking about with the ability to actually interact with external tools.
Like what kind of tools?
Search engines, APIs, maybe a code interpreter, basically things outside the LLM itself. It works in this loop. Think, act, observe.
Like humans do.
Pretty much. It tries to mimic how we solve problems. Reason about what info we need, take an action, like searching the web to get it, observe the result, and then use that observation to figure out the next step.
The example about finding out how many kids the members of Metallica have was really clear, using LangChain and Vertex AI, right?
Yeah.
The model figured out it needed to search, then it did the search action.
Exactly. It's this iterative cycle. Think, act. Observe, think, act. The paper does mention that making REACT work well requires carefully managing the conversation history, all the previous thoughts, actions, observations, and setting up good examples and instructions so the model knows how to use the tools properly.
This definitely feels like a big step towards more autonomous AI agents that can actually do things. Okay, last technique on the list. Automatic prompt engineering, or APE. This sounds like using AI to write prompts for us.
That's the gist of it. Automatic Prompt Engineering, APE, aims to automate the sometimes tedious process of finding really good prompts. Basically, you use another LLM. Yeah, kind of. You prompt an LLM to generate a bunch of different candidate prompts for your actual task.
Okay.
Then you evaluate those generated prompts, maybe based on how well they perform on some test data, using a metric like BLEU or Rouge, and you pick the best performing one.
The example about ordering a band t-shirt, getting the model to generate different ways a customer might ask for a Metallica t-shirt size S, showed that process.
Right. It can be really helpful when you need to handle lots of different ways users might phrase something, like in a chatbot, or when you're just trying to squeeze maximum performance out of a prompt for a specific task and want to explore more variations than you'd think of yourself.
Okay, wow, that was a really thorough tour of prompting techniques. Now, switching focus slightly, the white paper also had a whole section just on code prompting, which makes sense given how much AI is impacting software development.
Absolutely. LLMs are proving super useful for all sorts of code-related tasks. First off, writing code. They can help generate code in, well, tons of different programming languages. The example of the bash script to rename files showed how you can just describe what you want in plain English, and the model spits out the code. Of course, and the white paper is very clear on this, you absolutely need to review and test any code an LLM generates before you actually use it anywhere important. Seriously.
Good disclaimer. They even gave the specific steps for testing that bash script, which was a nice practical touch. Okay, so besides generating new code, they're also good for explaining existing code.
Yep. You can feed the model a chunk of code and ask it to explain what it does. That can be a lifesaver if you're looking at unfamiliar code, or even just trying to remember what you wrote 6 months ago. They use that same bash script example again to show this.
Handy. And then there's translating code between languages. The bash to Python translation example was pretty cool.
It is cool. It can really speed up things like porting code bases or using libraries from different ecosystems. The paper does warn, though, to double-check things like indentation, especially for languages like Python, where it's syntactically crucial. Platforms like Vertex AI Studio might handle it okay, but always check.
Good tip. And finally, for code, LLMs can help with debugging and reviewing code. The example with the deliberately broken Python script was quite revealing.
Yeah, that was a good one. They fed it the broken code and the error message, the traceback.
Right.
And the model not only pinpointed the exact error, I think it was using to uppercase instead of Python's.upper, but it also gave the corrected code and suggested other ways to improve the script.
So it's like having an AI pair programmer or code reviewer.
Kind of, yeah. It can spot errors, suggest better practices, make code more robust or efficient. Pretty powerful.
Okay. The white paper also briefly mentioned multimodal prompting. Can you give us the quick definition of that?
Sure. So everything we've mostly talked about, especially with code, has been text in, text out. Multimodal prompting just means using multiple types of input, not just text. So you might give the LLM text and an image, or maybe audio or video.
Oh, okay.
To guide its response. It allows for richer interactions. It's a big area of development right now.
Definitely sounds like where things are headed. Okay, so to bring all this amazing information together and give our listeners some really practical takeaways, the white paper wraps up with a great section on best practices for prompt engineering. Let's run through some of the key ones.
Absolutely. First, and maybe foremost, provide examples. We talked about one shot and few shot. Showing the model what you want with clear, relevant examples is just incredibly effective.
Like giving it a template.
Exactly. It's like teaching by showing.
Yeah.
And when picking examples, try to include those tricky edge cases or common mistakes to make the model handle them better.
Another big one. Design with simplicity.
Yes. Keep your prompts clear, concise, easy to understand. Avoid jargon or overly complex sentences. Cut out irrelevant info that might just confuse the model. The paper had good before and after examples, often simplifying things by using strong action verbs to say exactly what you want.
And be clear about what you want back. Be specific about the output.
Right. Don't be vague.
Mm-hmm.
Use those system or contextual prompts we talked about to spell out the details, the format, the style, the length, the specific content you need. Instead of just write about game consoles, say, write a humorous blog post for teenagers about the top 3 features of the PS5 and Switch. Specificity is key.
Okay, here's an interesting one the paper highlighted. Use instructions over constraints. What's the difference there?
So this is about focusing on telling the model what to do rather than spending too much energy telling it what not to do.
Ah, positive framing.
Exactly. Positive instructions generally guide the model better and might even allow for more creative solutions within those guidelines. Constraints telling it what to avoid definitely have their place, especially for safety or keeping things on topic, but try to lead with clear instructions. Like instead of don't mention Atari, a constraint, maybe say focus on consoles released after 1990, an instruction.
That's a subtle but important shift. Okay, another practical one. Control the max token lengths. We touched on this earlier.
Yep. Either use the configuration settings or explicitly ask for a certain length in the prompt, like summarize this in 100 words. It helps manage costs and ensures the output fits where you need it.
And for making prompts reusable, especially in apps, use variables in prompts.
Yeah, this is super useful. Instead of writing a new prompt every time, you create a template with placeholders, like tell me 3 facts about city. Then you can just swap in London, Tokyo, Paris without rewriting the whole prompt.
Yeah, makes sense. And then lots of experimentation is encouraged, right? Experiment with input formats and writing styles.
Definitely. Try asking questions versus giving commands. Try different words, different sentence structures. Some models might respond better to certain styles. You just have to play around and see what works best for your specific model and task.
And for few-shot classification, they had a specific tip. Mix up the classes in your examples.
Right. Don't always put all the positive examples first, then negative. Randomize the order so the model doesn't accidentally learn that, like the last category mentioned is always the answer. They suggest starting with maybe 6 diverse, randomized examples.
Good tactical advice. Also, stay current. Adapt to model updates.
Yeah, these models are changing fast. New versions come out, new features get added. It's smart to revisit your prompts now and then to see if you can take advantage of improvements or if anything needs adjusting. Tools like Vertex AI Studio can help manage different prompt versions.
And just like experimenting with input, experiment with output formats.
Right. Especially for tasks involving data, don't just default to plain text. Explicitly ask for structured formats like JSON or XML. The paperless benefits for JSON. It's consistent, focuses on the data itself, can actually reduce weird hallucinations, and handles data types and relationships well.
And if you do use JSON and it gets cut off and becomes invalid, they mention JSON repair.
Yeah, there are libraries like JSON Repair that can often automatically fix common issues like missing brackets or commas caused by truncation, can save a lot of headaches.
Very useful. And related to structured data, working with schemas.
Using something like a JSON schema defines the expected structure of the data up front. It gives the LLM a clear blueprint, which helps it focus on the important information and be more consistent.
Collaboration helps too. Experiment together with other prompt engineers.
Absolutely. Bouncing ideas off others, seeing different approaches, it can lead to breakthroughs you might not find on your own.
Okay, couple of specifics for chain of thought again. Make sure the answer follows the reasoning.
Right, logically.
Extract the final answer clearly, especially for self-consistency.
Yep.
And crucially, set the temperature to 0 for code T.
Yeah, that was an important one. Because COT relies on that greedy, step-by-step deterministic path, you generally want temperature at 0 to get the single most likely, hopefully correct reasoning chain.
Got it. And the final, maybe most crucial piece of advice for doing this seriously, document the various prompt attempts.
Cannot stress this enough. Keep detailed records. What prompt did you try? What model? What settings? What was the output? Good, bad, why? They even gave a template table.
Right.
This documentation is gold. It lets you track progress, figure out what works, debug problems, compare prompts when models update, save your prompts properly, maybe in a spreadsheet, maybe Vertex AI Studio. Keep them separate from your code. If you're doing RAG, document the retrieval part too. It's all part of that iterative loop. Craft, test, analyze, refine.
Wow, okay. This has been an incredibly thorough deep dive. We really covered a ton of ground today, from the basics of how LLMs work to configuring outputs through that whole range of prompting techniques, basic to advanced, then code prompting, a peek at multimodal, and wrapping up with all those essential best practices.
Yeah, it's a lot, but it really shows how much thought goes into effective prompt engineering. And, mastering it, it's definitely an ongoing process. It's about experimenting, learning, refining as these models keep evolving.
So for everyone listening, the real message is, take this knowledge, start playing around with it, try out these techniques, maybe check out the white paper for more details, but most importantly, start writing your own prompts. See what you can make these models do.
Exactly. And maybe as you start doing that, think about this. Now that you have a deeper understanding of how to guide these powerful AI models, what fascinating problems or creative endeavors will you explore with the art of prompt engineering?